Welcome back, everyone. Today we're going to discuss about biconditional statement. A biconditional statement is one of the types of statements in geometry where we use if and only if. Other ways to say it are P, if and only if Q, also P, if with the double F Q, and P, double arrowheads Q. For all of these, we are going to say P if and only if Q. P if and only if Q means P then Q and Q then P. That means that when you combine a conditional statement with its converse, you create a biconditional statement. A biconditional statement is a combination of a conditional statement. Let's have an example. A quadrilateral is a rhombus if and only if a quadrilateral has 4 equal sides. So as an example, my conditional statement for that one, which is my P then Q, is going to look like if a quadrilateral is a rhombus, then it has 4 equal sides. My converse, which is my Q then P, is going to look like if a quadrilateral has 4 equal sides, then it is a rhombus. For both statements, they're both true. Why don't you try working on this one? Example number 2. A point is a midpoint if and only if it divides the segment into 2 equal parts. Go ahead, I will give you a couple of seconds to construct the conditional and the converse statements for this one. Do your sentences look like this? Let's take a look. A conditional statement states that if a point is a midpoint, then it divides the segment into 2 equal parts. P then Q is true. Let's look at the converse. If a point divides a segment into 2 equal parts, then that point is a midpoint. Also true. You may need to flip your papers over and let us start practicing how to write a biconditional statement. For example, a rectangle is a quadrilateral with 4 right angles. Go ahead, take a moment to write this as a biconditional statement. Does your answer look like this? A quadrilateral is a rectangle if and only if it has 4 right angles. That's the biconditional statement for that one. Go ahead and try the second one. An acute angle has a measurement of greater than 0 degrees but less than 90 degrees. Go ahead and write down a biconditional statement for this one. The biconditional statement for that statement is an angle is acute if and only if it has a measurement of greater than 0 degrees but less than 90 degrees. Let us analyze the truth table for a biconditional statement. Go ahead and copy the table and try to fill it out with its truth value. Then we will discuss it together. Okay, let me see. If P is true and Q is true, the conditional statement P then Q is true. If P is true and Q is false, conditional statement P then Q will turn out to be false. If P is false and Q is true, we said from the very beginning that if your hypothesis is false, the statement becomes true. So if this is false and this is false, your whole statement still becomes a true statement. Go ahead and try to fill up the Q then P on your own first. So let us look at this one. Now the Q becomes your hypothesis. So it now becomes Q, then P. If your hypothesis is true and your conclusion is true, your Q then P statement becomes true. If this is Q then P and your Q is false, from the very beginning, you're making your whole sentence become true. If you have Q then P and your Q is true, but your conclusion is false, your whole statement becomes false. If it's Q then P and your hypothesis is false, then whatever happens to the P, your sentence still becomes true. Let us now take a look at the final P if and only if Q. I want you to focus on two things. You can take a look at this in two ways. Remember that if it's true, 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 your final statement becomes true. Also, what I want you to focus on are these two truth values right here. In a biconditional statement, if P and Q are both true or P and Q are both false, your biconditional statement becomes true. And those are the only two times that they're going to be true, if both are true, P and Q, or if both are false. The rest will turn out to be false.